Hi everyone, I am Ananthalakshmi. I am the IIT Madras ETDCS expert faculty. So here we'll discuss the second paper questions. Okay, great. The first, second, and third ionization enthalpies I1, I2, I3 of four atoms with atomic numbers n, n plus 1, n plus 2, n plus 3 is given in the table. We have to find what is the value of n. Okay, great. So they've given that n is less than 10 and the stable is given. And this is this question is entirely based on the periodic properties chapter. If you know what is the meaning of ionization enthalpy, then there is nothing to worry about in this question. Very simple, very simple. And just observe the table. That's it. So what is ionization enthalpy? Ionization enthalpy is the amount of energy required to remove an electron. Okay, amount of energy required to remove an electron from an atom. Great. So when it will be very difficult to remove an electron from an atom? When the atom is at stable configuration. So when an when an atom is at stable configuration, stable noble gas configuration, then you will have to provide very high energy to extract the electron from it. Basically, you are disturbing the stability. So you need to pay high price. So here the price we have to pay is energy. And that energy is called ionization enthalpy. Great. So now based on this, we have to find what is n. For making our life simple, they have given n is less than 10. Okay. So now our job is to observe and get insight from this table. So we can see for n, this is the thing. For n plus 1 ionization enthalpy is this. For n plus 2, this. N plus 3, this. Now, just tell me, where do you see an unusual jump in ionization enthalpy? I would say in first observation only, I can see this. From 96 to 4562, there is an enormous jump, right? Which means for n plus 2 atomic number, its first ionization enthalpy was very less, 496. Means it could easily lose an electron first. But its second ionization enthalpy so huge, which means the atom after losing one electron, it should have been in a stable configuration. That is why its second ionization enthalpy is so huge. Do I make sense? I should be making sense. So we know from structure of atoms, for this to be stable, its configuration should be what? 1s2, 2s2, 2p6, right? I mean, every orbital is fully filled configuration, which means 10 electrons is the stable configuration, right? So it means that before losing this electron, if this is 10 electrons, then before losing this one electron, it should have been 11 electrons. So when at the initial state, it is having n plus 2 electrons. So our answer is pretty straightforward. We can say n plus 2 is 11 and hence n is 9. Yeah, so this question was easy, simple. You just need to observe. It's pretty simple. Now let's move on. Okay, this question is from chemical bonding chapter. Let's read it. Consider the following compounds in the liquid form. Okay. When a charged comp is brought near their flowing stream, how many of them show deflection as per shown in the figure? Okay. So what you see in the figure is a comp, and here these compounds we are trying. Okay, we are bringing these compounds near this comp. This is a charged comp. Okay, this is a charged comp. Okay, so this is showing deflection. So we are asked to find how many of this show this deflection. So this is pretty easy. So first of all, you should understand why they are showing deflection. It is because of the electrostatic force of attraction. Like charges repel, unlike charges attract. That is something which we learn in 9th standard in science textbook, right? It's pretty forward. So for this compound to show deflection, the point is the compound should be polar in nature. Okay, they should be polar in nature. Our job is done. We just have to see out of all these molecules which of them are polar. If they are polar, then they show deflection. So let's take these compounds one by one. O2, no. O2 is not polar, definitely, because it's symmetric and equal atoms. No, O2 is not polar. HF, yes, it's definitely polar because of the electronegativity difference between H and F. H2O is also polar. Like we learn polar and non-polar molecules in chemical bonding chapter. NH3 is polar. H2O2 is polar. Again, CCl4 is not polar. Why? Because it's tetrahedral and all the surrounding atoms of carbon, they are the same. So net polar effect will be 0. So CCl4 is non-polar. CHCl3 is polar. CCH6 is benzene. No way, it's polar. It's non-polar. CCX5HCl, yes. CCH, which is chlorobenzene. Yes, this is polar, right? Because of the chlorine. So which of them was not polar? I'll circle. This is not polar. So which of them are polar is 1, 2, 3, 4, 5, 6. So answer is 6. Yes, so let's move on. No, I didn't delete it. Here. Okay. This is a question from, okay, this is a combination of, no, this is basically chemical kinetics question only. It's an easy question, let's just read it. Which of the following are correct for the given reaction? Yes. So first of all, understand what is this reaction. So this is an alkyl halide, some RX, reacting with a base, and okay, this is basically a nucleophilic substitution reaction where OH is the nucleophile. It substitutes the halogen, which is bromine. So this bromine leaves as NaBr and OH is here. So basically Br is replaced by OH. So definitely we should understand that this is an SN1 reaction. Okay, SN1 reaction means it depends only on the substrate. The rate determining step is the halogen leaving step. Okay, so rate, we can say rate is only dependent on the substrate, which is the alkyl halide RX. Okay, fine. Okay, now P naught is the initial concentration of P. So that is P naught is the initial concentration of P, means initially we have P naught alkyl halide, which is here it's tertiary bromide. Okay. Great. Now let's solve each options one by one. So we know that in a first order reaction, okay, this is a first order reaction, SN1, right? First order reaction. The half-life, T half, is a constant. Yeah, this we'll learn in chemical kinetics. And initial rate, okay, this is correct basically. Okay, so why is initial rate is not changing with initial concentration? No, because initial rate is K into P naught, right? It should vary with P naught, so this is wrong. I mean, it should have been a linear graph instead of this. That is wrong. Now, what about this? C, Q by P naught. So what is Q? Q is the product concentration by P naught. P naught is the initial concentration, which is a constant. So how do you, so basically we should know how Q is varying with time, the product. So we definitely know that the product will increase only with time. But how can you say that product increases like this exponentially? It won't go to infinity, right? It should be coming to a saturation. It won't increase to infinity. It will grow till the whole uh, reactant is converted into product. So mostly it should saturate to a value 1. Okay, so this is also wrong. And what about this? Ln P by P naught. So, okay, for first order reaction, we should know that P is given by P naught e power minus KT. So, if you take ln of this, ln P will be ln P naught minus KT. Okay. So the slope is negative, minus K, and not positive. So here this is also wrong because we should get a negative slope. This is wrong. So only correct answer is A. We are done with that.